Today I'm going to discuss number theory applications. First of all, what is a number theory and why is it important? Number theory is a branch of pure mathematics devoted to the study of the natural numbers and the integers. The number theory helps discover interesting relationship between different sorts of numbers and to prove that these are true. Number theory is partly experimental and partly theoretical. Experimental part leads to questions and suggests way to answer them. The theoretical part tries to devise an argument which gives a conclusive answer to the questions. What are the different number theory applications? First one is error correcting codes, numerical integration, computer arithmetic, random and quasi-random number generation, and lastly, cryptography. How is number theory used in cryptography? Number theory plays an important role in encryption algorithm. Cryptography is the practice of hiding information, converting some secret information to not readable text. Number theory were used to develop increasingly involved algorithms, step-by-step procedure for solving a mathematical problem. What are the applications of prime numbers? Prime numbers are also used for hash tables and pseudo-random number generators. Some router machines were designed with a different number of pins on each router, with the number of pins on any one router either prime or co-prime to the number of pins on any other router. Discuss briefly the early modern number theories: Fermat, Euler, Lagrange, Legendre, and Gauss. In 1638, Fermat asserted that every whole number can be expressed as the sum of 4 or fewer squares. He claimed to have a proof that did not share it. Fermat stated that there cannot be a right triangle with sides of integer length whose area is perfect square. In number theory, Euler's totient function counts the positive integers up to a given integer n that are related to prime to n. In other words, it is the number of integers k in the range of 1 less than or equal k less than or equal n, for which the greatest common divisor nk is equal to 1. Joseph Louis Lagrange was the first to give full proofs of some Fermat's and Euler's work and observation. For instance, the four-square theorem and the basic theory of the misnamed Pell's equation, for which an algorithm solution was found by Fermat and his contemporary. Adrien Marie Legendre was the first to state the law of quadratic reciprocity. He also conjectured what amounts to the prime number theorem and Dirichlet's theorem on arithmetic progression. He gave a full treatment of the equation ax2 plus by2 plus cz2 is equal to 0 and work on quadratic forms along the lines, later developed fully by Gauss. Carl Friedrich Gauss proved the law of quadratic reciprocity and developed the theory of quadratic forms, in particular defining their composition. He also introduced some basic notation, congruences, and devoted a section to computational matters including primarity test. Thank you.